Hello, everybody. Today, I'm going to be using my whiteboard talk in order to discuss the field of science that I study, which is known as Karst Hydrogeology. I'd imagine that a lot of you may not know what this is, and that's fine. That's why I'm giving this talk about what it is. I'm going to be giving an overview of what Karst Hydrogeology entails, as well as some of the common features that we can associate with this and see here in Tallahassee. So first of all, before we talk about karst hydrogeology, it might be important to discuss what hydrogeology is. And so we'll break that down as geology is just the study of the earth, the study of rocks. Pretty simple. But when we add hydro to it, hydro coming meaning water, what we're really referring to is water that is found underground or stored within rocks or the earth. Even though rocks may seem solid, there's actually a lot of empty space and void space that make them really ideal candidates to hold water, really easily store water. You can think of them kind of like a sponge. They have a lot of holes and ability to hold water. So hydrogeology is associated with looking at that water underneath the ground, groundwater. Now karst, you may not have heard of this word. Karst comes from, I believe it's Polish, or Slovenian, one of the two, and it refers to dissolution. Dissolution or dissolving. Even though rocks, we typically think of them as hard, there's a kind of a spectrum of how hard rocks are, and some rocks are actually fairly soft. One of those rocks is known as limestone. Limestone is the primary rock type here in Florida, and something to note about it is it's relatively soft. You can probably, in some cases, you can, chip it away with your finger. And on top of that, one notable aspect about limestone is that it frequently is described as having a blocky texture, blocky. Then what's special about limestone is that it has the nature to fracture in blocks, or kind of this 90-degree pattern that you can see here. This here is the universal symbol for limestone, this kind of offset checkerboard pattern. In any geological map that you look at, this is the symbol that they're going to use because of this blocky nature that it has. It tends to fracture and create cracks like this. So this is really important in terms of karst for understanding how karst occurs. So if you have here where we took a slice of the earth and we're looking at this block of limestone, this slice of limestone, it's going to rain on the surface. So we have a little rain cloud here and some rain. Now, it's blocky. All these lines are essentially fractures or cracks, as you could think about it. So water is going to very easily flow through these cracks, even though there's a lot of space within the rock. If you have the choice to flow through the massive rock or just a crack in the rock, water is going to preferentially flow in that empty space, that crack. So it's going to flow through this fracture system fairly easily. So that's why blocky nature of limestone is important, but it's also soft, so it's going to be easily dissolved. Water is going to dissolve it here at the surface, so it's going to eat away at it. Rainwater is naturally acidic, and limestone reacts with acid to dissolve. Now, it's not only going to dissolve here at the surface, but it's going to dissolve all the way that it's everywhere that it's been flowing through the conduit system. So all through the crack system. So all through here, it's actually going to start eating away, chewing away, and dissolving this rock. And what you're going to end up getting, I'm going to use my eraser here to dissolve my rock. And what you're going to get is kind of here we had something like this, is a very long stretch of empty space. And you can think about this as a cave. It's rock that used to be there, but it was dissolved and transported away. So it's just empty space. It's a cave. If it's really long and long shape, what we're going to call that is a conduit. This is a karst conduit. You can essentially think about this as a pipe because it's surrounded by rock. You can think of these as kind of the walls of the pipe, and then the physical pipe itself is the conduit. Water is going to very rapidly be able to flow through the conduit because it's empty space. Water is just going to, you can think about it as a pipe or a garden hose. Water is going to easily just flow through it linearly. This is really important. One of the conduit systems that is most famous worldwide is the Wakulla conduit system, south of Tallahassee in Wakulla County. It's the largest mapped conduit system in the world. Cave divers can actually, these things can get big enough that cave divers can go down there and map it. I believe that they found in Wakulla, they've done a lot of, they've done a lot of cave diving, and they found a lot of Paleo-Indian fossils, not fossils, artifacts. They found fossils like mastodons from the ice ages within these conduit systems. They're really cool and very large. They can be very large. And they also transmit water extremely quickly because, like I said, if you had to make your kitchen sink out of a rock, or you can make it out of a pipe, you're going to be a lot more efficient if you're flowing through open space in a pipe. So we can think about these conduit systems as pipe work or plumbing. Going forward, so we've created a lot of empty space here in this conduit system. But if they get too big and too close to the surface, what can happen is we can quite literally have a cave-in. If we don't, gravity isn't going to stop pulling down on the roof here. And if it gets too heavy for, if we dissolve too many of the support systems, we're going to have a collapse. And think about it like this. We put all the roof material here at the bottom. And it's going to be a kind of this depression here at the surface where all the roof fell in. And what we're going to call that is a sinkhole. It's a hole that has sunk in the ground. There's a lot of sinkholes in the area. Florida is very known for having them because it is a karst environment. And with these sinkholes, once all the material falls to the bottom, they can clog up and they can actually fill with water and become lakes. Many of the lakes in the area, Lake Bradford, Miccosukee, Jackson, Lafayette, Ammonia, Piney Z, they're actually sinkhole lakes where they've been a sinkhole that have filled up with water. So right now, we have a storage of water that's loosely connected. Water can still pass through here a little bit. A pipework that can very easily transport water long distances. And what can happen is that if this conduit intersects the land surface again, water is going to flow out of it. It's just like I said, it keeps saying it's a pipe work, it's a garden hose, and water is going to flow out. And what we call, and it's going to actually form a river, but what we call this point here is a spring. It's where groundwater exits the ground and becomes surface water. And it's connected to a karst conduit. It's known as a karst spring. In this area, we have Wakulla Springs. We have Wassissa Springs, the Osceola sinks and rise, Natural Bridge Spring. We have a lot of springs that can they're very large. The presence of the karst conduit allows for a lot of water, very large springs to occur. There's a lot of transport in this area. So, as a review, Karst hydrogeology is the study of groundwater, how water flows through the ground, specifically in areas that have dissolved rock or karst features, such as conduits, which are these large cave systems that act like nature's plumbing or pipework. We have sinkholes, which are where the the roof of those cave systems have collapsed and created a depression on the land surface that can occasionally turn into lakes if they fill up with water. And we have springs where that water flows through the underground and reemerges at the surface, usually at the start of a river. These are all associated with karst, which occurs in Florida here. It's associated with limestone because it's soft, it can be easily dissolved, and it has this blocky structure that allows for these very large systems to form. With that, thank you for listening, and have a good day.